Hello, everyone. I'm glad to be here with you. And today we will speak about Kotlin multi-platform and how we integrate Kotlin multi-platform at Deezer. Here is Geoffrey with me. Geoffrey.
Hello, I'm Geoffrey Metais. I'm the lead developer of the core team at Deezer, Android. And I'll speak today with Anthony because as Android developer, we are a huge contributor to the Kotlin effort in Deezer.
And so I'm Anthony. I'm in charge of the cross-platform project at Deezer and the lead of Kotlin multi-platform today. So today we will first see how we assess the technology, the different technologies that we test, etc. Then we will see the different changes that we met and the solutions that we found to these changes. Then we will expose our vision of the future of Kotlin multi-platform at Deezer, and finally we will summarize a bit all the presentation for you. So the first question is why cross-platform? It's really easy to understand that instead of having 3 teams developing the same business logic for 3 different stacks, we can have only 1 team focusing on this business logic and let the stack-specific team work on the more specific needs. This has a great advantage. This enables us to have the same behavior on all the 3 different platforms. It's easier to maintain, easier to debug, and easier to improve. Then how we choose the technology? Well, we have done a benchmark. We dress up a list of different technologies that we wanted to test, and a list of acceptance criteria to fit with the Deezer expectations. Here you can see that we have Go, Rust, Swift, and C++, which are some build native technology. That means that it builds some WebAssembly for web. This is a bit painful for us because we are not ready to integrate WebAssembly. And also it triggers a GNI problem. Then you have Flutter. Flutter is a framework to create an application from scratch for multi-platform. At Deezer, we don't want to rewrite the entire application. We just want to rewrite some part of our application and to focus on the business logic. So that's why we choose Kotlin. Another advantage of choosing Kotlin for us is that today we have already 1,500 developers that can help us to put in place to set up this technology. Another great advantage is that for iOS we can build some Dot framework. For Android you can build some Jar, but also for web we can build some Node packages, which is the best way today that we interact with external library. Just a little warning, this technology is still young, is still in beta. So we can see that as a risk, but for us it will be, it was a risk that could be taken because if we mess up, we can still reuse our code for the Android app. What is quickly Kotlin multi-platform? So Kotlin multi-platform is an aggregation of Kotlin JS, Kotlin JVM, and Kotlin native. And these 3 technologies communicate through a common channel. This enables us to have a clean architecture, as you can see. We have a common main folder, which will contain the whole common code. And then we have some specific folder when you can do every specific thing that you want. To communicate between the common code and the specific code, you have a new paradigm, the expect actual paradigm, that enables us to define some class, function, or members that should be defined, redefined, rewrite into our specific code. So here you have an example for JS, for example. Today at Deezer, what we wanted to do with the Kotlin multi-platform was to focus on a low-level component, the player component, which will play with some sub-components. So here in yellow you have the KMP part, and in blue the stack-specified part. You can see that our main library, which is the Xplayer, is communicating with some KMP subcomponent, but also with stack-specific components. So now that we know why and how we choose Kotlin multiplatform, we will see the different changes that we made. There are two kinds of changes, the technical changes and the human changes. I will begin with the technical changes. The first change was the bundle size for JS. In fact, at the very beginning of the integration of Kotlin multiplatform at Deezer, the Kotlin JS compiler was a legacy one with no DCE, dead code elimination, which means that the complete code was embedded into the package. This led us to a huge package size. The technology was improving, and with some improvements, a new compiler came up, the IR compiler, which is way more performant and includes a DCE. This means that we have now a lighter package size. To give you an example, our library today is around 37 kilobytes. And to give you another example, React, which is the biggest external library used by our web team, is around 30 kilobytes. Kotlin JS AR is still new, it's still in beta, but it enables us to have the support of TypeScript. But as it's young, we have some missing type. Here is a list of some missing types that we face up. And with the evolution of Kotlin, we have some of these missing types that are supported now. But for now, those missing types lead us to something like that. When you have an enum, for example, in Kotlin, you have it's transformed into an any type. And if you have a long, it's transformed into a Kotlin long, because here, instead of a Kotlin long, we wanted to have a number, but it's not the same precision for them. So for now, we have something like that. So how we assess this problem? We have done what we call the JS facade. It's a kind of wrapper that enables us to import some JS type as a Kotlin type and to export some Kotlin type as a JS type. As you can see, it's a bit painful to write. This is just the code for our previous example, so it's a bit painful to write, and it's a lot of boilerplate. So to avoid to do this by hand, we have developed a KSP plugin, which enables us to auto-generate the JS facade. Which this KSP plugin, we have two benefits. So we don't have to do the JS facade by hand, but also we don't have any specific code into our code base. So we just have some common code. The usage is really simple. We just add an annotation right above the classes and the types that you wanted to export on the JS side. And to finish, this project is actually open source, and if you wanted to contribute, feel free. Now that we have seen the limitation of JS, we also have some limitation with iOS. The first one is that if you have 3 different modules and you wanted to export it into some 3 different frameworks that communicate with each other, it's not possible today. Today, you need to package all the different modules into only one .framework. This leads us to another problem. When you do this, you can have some conflict naming. For example, if you have a method with a name into the module A, and we have a method with the same name into the module B, well, you will have a conflict between the naming into the .framework. To avoid this, we put some linting rule that enable us to avoid to have the same name of method into different modules. Another problem was that when we set up the cross-platform project, we wanted to include all the stacks working with us and working together and collaborate. But the first thing that you can see is that we are not working with the same language. And for example, Switch and Kotlin are really different at some point. This leads us to some technical issue about the code review, and so the iOS team feel a bit not integrated into this project. To avoid this, we put in place a continuous integration that generates for us some headers and put it into specific repository. This enables us to deliver some differencing for only on the header parts, and so the iOS team can review only these differences. Here you have an example just for iOS, but we have done the same thing for GS2.
We now see the human part of the problem we faced adopting this multi-platform, doing just a multi-platform project. We have to understand that each one of us comes from one specific platform with its own development environment, it's like a specific culture with different patterns, different naming conventions, different paradigms, so that this is a different way of seeing things. So is a light example of how we call a callback like on Android or web, it's on track change, but it's named differently on iOS, and this kind of little difference make a huge one when we, well, at review time, because at review time we are used to have a specific syntax, specific order, specific designs, and seeing new ones is not easy, it's harder to read, to understand, it's an extra effort. So that's a blocker for the technology adoption. We explored some solutions. We tried some stack-specific wrapper, like the facade. We tried to adopt the pattern who suit the most of the developers, and not specifically the best one for architecture or the best one for every platform. And in the end, we assembled the whole team, composed of the 3 stacks plus Anthony, to define common guidelines suited for the KMP project, and in the end having a correct API. This guideline has been agreed by everyone and has to be respected by everyone. And this was the first step to move forward and work really together for real for the first time. The adaptation of the developers is also important. First thing to understand is that we have to think cross-platform when we write our code, especially for Android developers. We know Kotlin, but we don't know multi-platform. And that's very important. We don't just have to remove the JVM dependency. We have to think about the output it will produce and not think about the Android-specific platform needs or problems or features, but what will work everywhere. Other developers have to understand that Kotlin multi-platform is not Android either, because Kotlin is the main Android language, it's seen as an Android technology, which is not the case. So that's also is a blocker for other teams, because they see it as an Android framework invading their own safe space. For this particular point, it helped to have Anthony, which is not an Android developer, nor an iOS one or a web one. He comes from another technology, so he is quite agnostic and objective, so it helped to adopt, and so he can take the decisions. And lastly, we have to learn to work together, because we used to race, to compete in parallel. Like we develop the same feature on Android and on iOS and on the web at the same time, but that's 3 times the different work. And we have now this team who never worked really together to do it for this time. And we saw the split editors example. That's a great one, because this is an extra effort we made to onboard everyone and to see that A Kotlin PR is easy to read for an Android developer. It's exactly what we will get, what the API will have to integrate and manipulate. But it's not the case for the other stacks. So it was really cool for them to have explicitly what they will have to handle once the PR will be merged to make a clear review and a good approval. And now this project is going pretty well with teams onboarded. We have to think about what to do now, how to continue. That's pretty sure we'll still improve our project or the developer experience we have on it, like with the KSP plugin. We'll have to define the strategy we want to adopt permanently. What will be the scope of the multi-platform libraries? Will we move all our SDK to multi-platform or just some part and keep stack-specific ones, like the player itself, for example? That's something really hard to move on multi-platform because it's really platform, really bound to the platform. And for this strategy, we'll have to create a whole team for KMP. So we are looking for people to join Anthony on this team to have developer 100% focused on this multi-platform effort and not switching from different contexts and possibly not tied to any technology and really objective people. So you can apply to join us. And finally, the takeaways we get from this first year with KMP. This is really promising. There are some caveats, but we've gone quite far so far. It works pretty well. We have one great bonus that we didn't anticipate, the APIs. In Kotlin, even if we don't implement a module in multi-platform, we can inject like the player itself. The base player is stack-specific and injected by each client to the library. But with it, we define a common API defined in Kotlin multi-platform and implemented by every stack. So the three teams have the very same API to implement and to respect. And that's really powerful and really few constraints because there's no code in it. So it's easy to compile it in multi-platform, to deliver it to everyone and use it. That's just interfaces and models.
And to finish, from a Deezer point of view, there is still plenty of things to improve. But we are already confident for the future because this technology shows us that it's really promising. We developed a full cross-platform strategy at Deezer, and we wanted to build a dedicated team. This dedicated team will have the mission to facilitate the integration of our library into the different stacks, and to build some more native-friendly library for the other stacks. And that's it. Did you have any questions?